Quick note to our listeners, we need your help. We're close to 1 million views on YouTube, and we have over 5,000 subscribers. But if we can get to 10,000 subscribers by the end of this year, that will allow us to raise money for the Finding Genius Foundation and our study to help those suffering from anxiety, depression, and PTSD. Please just take a second and subscribe to the podcast. And if you can, like the video. That'll help us get more listeners. It'll help with the YouTube algorithm. And again, help us reach our goal of 10,000 subscribers and 1 million views. We're going to hit the 1 million views, it looks like, hopefully by May of 2022. But the 10,000 subscribers will be harder. That's going to take until the end of this year. Thank you. Join over 350,000 people just like you who are taking control of their wellness journey with Viome. When it comes to choosing the right food and supplements for you, don't guess. Test. With Viome's Health Intelligence Test, you get over 30 health insights based on your unique biology and your gut microbiome. You also receive personalized food recommendations and precision supplements formulated literally just for you. Use code GENIUS to get an extra $20 off a health intelligence test. Visit Viome.com to shop now.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have a returning guest, Dr. Richard J. Johnson. He's the Thomas Burrell Professor of Medicine. He's part of the Division of Renal Diseases and Hypertension at University of Colorado. He has a new book that I recently just got, but haven't had a chance to go through. Nature Wants Us to Be Fat. We were just talking about the picture on the cover. It's got a picture of a carrot. It looks like it has two legs, and it looks like, I guess if a person was a carrot and they were crammed into a pair of tight pants, that's what it would look like. But it's an interesting cover. So, Rick, thanks for coming back. I appreciate it.
It's a pleasure. It's just a pleasure. Thank you for inviting me.
Well, tell me, what motivated you to write this new book? What's the premise of it?
Well, I'm a researcher, and I've been doing a lot of research on the etiology or the cause of obesity. And our work some years ago led us to discover that there's actually a biologic switch that animals use to become fat, and that animals normally regulate their weight really well, and when they want to put on a fair amount of fat, they'll do so by activating a biological switch. And when they do that, they activate this whole process where they will eat more, put on fat, they'll be foraging for food, they'll become insulin resistant, all kinds of things that we know of because it seems to be happening to us all the time. And when we were identifying that this was an actual switch, it wasn't a behavioral problem of just saying, hey, I'm going to eat more and exercise less. It's like a program that gets turned on. And so we've been doing a lot of work on the switch, and over the years we've been able to identify what activates it and how it can lead to disease, why people are getting it, why people are activating the switch, and kind of linking it with a lot of conditions from not just obesity and diabetes and high blood pressure and heart disease, but also even conditions like cancer and dementia and behavioral disorder. And so because of that, I thought I should write a book. I had written one some years ago, The Fat Switch, that kind of talked about the discovery of the switch, but we've gone so far since then that it just seemed like it was time to bring another book to the market, to the public, and to let them know about this science.
Yeah, with modern humans, we're making our choices, or I think we're making choices, regardless of season. But for an animal that maybe listens to the seasons or is just affected by what's going on externally, what is the trigger composed of? I would think it's not just one thing, but maybe it's lighting conditions as winter approaches, and temperature, and availability of foods, and like what composes this trigger?
Yes. So there's two triggers actually, right? So there's the trigger that stimulates the animal to start gaining weight. And then there's the actual trigger when they hibernate, and they switch from eating a lot to burning the fat. So there's really two phases. There's what activates the switch to actually make an animal super hungry, where it's like, eating 2 or 3 times as much as it normally eats every day and putting on, really dramatic weight. So there's the switch to turn on, there's a turning on of the switch, and then there's a turning off of the switch when the animal actually hibernates or migrates long distance and then start. And I think you're talking about what initiates the eating, or are you talking about what initiates the hibernation?
Oh, what initiates the eating first? The hibernation.
Yeah, I can
about
talk about both. So, it's been a mystery, but what we found was that a lot of animals seem to trigger the switch by eating a lot of fruit. And we think of fruit as being healthy, right? But fruit contains a nutrient called fructose. And fructose is also in table sugar. It's also in high fructose corn syrup. It's a carbohydrate. It's a simple sugar. And it's why fruits taste. And what happens is when fruit increases in amount, it's often in the fall, and the fruit ripens kind of late fall in many settings. And when that happens, a lot of animals will shift from eating like insects or other foods to eating a lot of fruit. And when they do so, they end up eating a huge amount of fructose. So it's not like eating 1 or 2 fruits a day like what we do, but rather these animals can eat hundreds of fruits in a day. And when they do that, they get enough sugar and fructose that they start activating them. So it seems like fructose is a major way to activate the switch. And like bears, they'll eat like as much as 10,000 berries in a 24-hour period. And when they do that, they're poor researchers who go out there and count the number of seeds in the scat. That is a bad job, let me tell you.
If you or I did that, we would probably be in the bathroom for a long time, pooping our lives away,
There you go. Yeah, if that was the way we got fat, it would take some time. But anyway, when a bear does it, they can gain, 10 pounds, 8 pounds a day from all the food they're eating. And it makes them hungry and eat more and put on fat. And that's what kind of activates it. Now, what triggers the switch to hibernation, has also been a bit of a mystery, but there's some evidence, pretty good evidence, that it's triggered by the removal of available food. So like suddenly it starts getting cold enough that the animal can't find enough food. That seems to be a major trigger, or there's not enough water. That also can trigger hibernation or long distance migration. So it seems to be triggered by that.
Well, is just the appearance of fruit like, it's, the plants that are around an animal have now bore fruit. So the animal sees that and it says, I know that stuff's good. And is it a self-triggering trigger just because of availability, or are there other elements that cause the animal to look for and seek out fruit and crave it?
Well, so we did experiments in animals where we worked with animals that had no taste. So we genetically modified them so the animal could not taste anything. And they'll still seek out fructose. So if you give them 2 bottles of water and one's regular water and one has fructose or sugar water, the animal will prefer the fructose water and it will still get fat from it. So even it's not a matter of taste. It's something that's deeper than that. It's actually related to the metabolism, and it triggers, a liking for it. Even if you can't taste it, you can figure out, I don't know how they figure it out, but if it's smell or whatever. But
Discover how your gut microbiome is impacting your cellular health, immune health, and how you're aging from the inside out with Viome's Health Intelligence Test. Collect your samples, send them to the Viome lab, and within 2 to 3 weeks, your health scores and food and supplement recommendations will be available to you right in your Viome app. Visit Viome.com and use code GENIUS to get an extra $20 off your health intelligence test.
Do you think this is a cellular-based trigger where the cells in the creature's body, for some reason, they're reacting to exogenous events, again, temperature, availability of food, whatever it may be, and they're turning on signaling to say, seek out fruit?
Yeah, I think yes, for sure. I think that there's a biologic mechanism driving it, because if you block, as I say, if you block taste, you'll still seek it out. If we block the metabolism, they don't care for. If we block fructose metabolism, animals don't care for. So it relates to the specific metabolism. There's also this kind of very interesting thing that the plants sort of know how they want to do it. Of course, plants can't think, but evolutionary processes have kind of led to a symbiosis between plants and animals on this. So, has seeds that it wants to use to make a new plant. And so in the fruit, those seeds are immature in the beginning when the fruit is immature. So, and at that point, there's not much fructose because an immature fruit is often, sour or tart. It doesn't have much sugar. And then as the fruit ripens, the sugar content goes up, the fructose content goes up. And so does the seed. The seed tends to mature so that by the time the fruit is ripe, that's when it's ideal for the animal. The animal eats it and then disperse the seeds in its poop and so forth that allow the tree to, for more trees to come. And what's interesting is early in this fruit in the season, the fruit will be very high in vitamin C. And we found that vitamin C actually counters the switch a little. I recommend everyone to take 500 milligrams of vitamin C. And the vitamin C actually partially blocks the fructose effects. And so when a fruit is tart, the vitamin C content will block the beneficial effects of fructose to stimulate weight gain for these animals because it's beneficial for them, right? And so then the vitamin C content goes down as the fruit ripens. So again, then the fruit becomes more powerful for the animals. So it's sort of like trying to get the animal to wait till it's really ripe. And bears, for example, will increase their intake of fruit dramatically after the first frost, and the frost tends to sweeten the berries and grapes. So there's a definite relationship.
Okay.
So anyway, so these animals, when we found that fructose could act as a biologic trigger to suddenly make an animal become hungry, we got very interested in why it was that particular nutrient. And we also, started exploring, what exactly constituted this biologic switch.
I know fruit juice, there's no fiber to maybe stabilize the glucose reaction, or the sugar uptake. And from what I've heard, berries are very low in sugar, but I guess if you have enough of anything, overwhelm you sugar-wise, or, does the fiber play any role in mitigating the role of fructose?
You're absolutely right, Richard. So like if we eat a natural fruit, there's a lot of fiber in it, and the fiber slows the absorption of the fruit. And the way the fructose activates the switch, it's actually related to the concentration of fructose that the liver sees. So if you eat one fruit, especially like with a meal where there's other foods there, the fructose absorption gets slowed down by all the other foods and also by the fiber. And then in addition, the fruit has vitamin C, and we tend to like tart fruit that often is high in vitamin C. We like the vitamin C. And so what happens is the fructose in an individual fruit doesn't do as much because of the vitamin C. And there's also flavonols, and flavonols also are in fruits, and they can block some of the effects of fructose. So when you eat a natural fruit, we're not getting that much fructose that's really active. It's coming in slow. And the other thing is that my friend Josh Rabinowitz, a scientist, discovered that the intestine kind of inactivates about 4 or 5 grams of fructose when you eat it. So when you eat a natural fruit, it actually converts that fructose to glucose, which is just a regular fuel. So, eating 1 or 2 fruits does not cause a problem for us. Now, if you're an orangutan and you just ate 100 fruit in a tree in the last 3 hours, now you're getting the fructose, okay? It is overwhelming the intestine. It's overwhelming everything. Or if you, Richard, decide to make a smoothie and you're going to put, 7 fruit in there and make this very sweet juice in which some of the fiber has been lost, and so, then you're going to activate. So apple juice, for example, has as much fructose as a soft drink, maybe even more. And we've done studies with apple juice, and it really can activate the switch. But a natural fruit does not. I mean, certain fruits are much higher in fructose than others. So I have in my book, I have a chart, of how much sugar is present in each type of fruit.
What would happen if I ate like a couple of chewables of vitamin C right before I ate a fruit? Would that
It
do
would
anything for
help.
me?
It definitely would.
It,
Yeah,
it would further blunt the uptake of fructose or the conversion of it?
it would block the effects of this. We did a pretty
Really?
cool study. So there was a, at the time of the great dinosaur extinction, when this asteroid plummeted and hit the Earth 65 million years ago, there's some evidence that there were some primates that were actually alive. The first primates, our ancestors, were actually alive at the time of and some of them survived. And what was interesting is there's evidence that most of them, there were two main groups. There were the wet-nosed primates, which went on to become lemurs, and then there were all the other primates, and they were called dry-nosed primates. And they actually got a mutation in vitamin C at that time, because we used to make vitamin C in our going way, way back in our past. We would make vitamin C. And when we lost our ability to make vitamin C, it was actually a kind of a move so that we could be more sensitive to the effects of fruit, because when that asteroid hit, the world, went into an impact winter. It became very dark because all this ash got into the atmosphere and it blocked the sun. And so there was a lot of plants and animals went extinct, and things like fruit would have been very hard to find. And these little guys, our primate ancestors, were living on fruit. And so to help maximize the ability to store fat from fruit, they needed to do something. And when they got that mutation, which occurred by accident, but it was immediately a survival benefit because it allowed the fructose to be more powerful. And the way we proved that was we took laboratory mice that had their vitamin C, their ability to make vitamin C, we knocked it out. So they were vitamin C deficient, just like we are. So if you don't give them any vitamin C, they get scurvy, just like us, and that's a bad disease. So all the animals had to get some vitamin C. But then what we did is we gave one group large amounts of vitamin C so that they had really healthy blood levels. And the other group, we gave small amounts, and so that they got blood levels sort of like people who are overweight, who tend to have low vitamin C levels. And so what we did then was we gave them high fructose corn syrup, and both groups ate the exact same amount. Okay, so they were all eating the same amount, but guess what? The group with the low vitamin C, they got much fatter. Because the vitamin, they didn't have enough vitamin C to block the fructose.
That's what I was going to ask you is, what if there's a vitamin C diet, like before each meal, and I'm just assuming a chewable, like, if I have a chewable 200 milligram or 250 milligram vitamin C tablet, what do you think? If I have carbs, would it affect me in the same way if I had fruit? Or,
it would protect you either way a little bit. But now, here's so it's actually a great idea to suggest to take it right before a meal as opposed to once a day. It's brilliant, Richard.
What I've been doing recently is my wife and I, we take like digestive enzymes every time we eat. It helps. It creates a smooth transition from full to hungry again. You don't feel like blah, so it seems to really help. So maybe adding this would be good too.
Well, here's a couple pearls about it. The first thing is, something like 250 milligrams before each meal would probably be ideal. If you actually eat a large amount, like grams of vitamin C, vitamin C can be metabolized to a substance called oxalate, and that can make kidney stones. So if you're eating a large amount of vitamin C, like 2 grams a day or something, it can cause kidney stones. So that's why I recommend only having like 250 or 500 milligrams a day. The other thing is that there's a little bit of evidence, enough to scare the athletes, that if you're taking large amounts of vitamin C, it can, when you exercise, your muscles actually, not only do they get stronger, but the energy factories that are in your muscle, what we call mitochondria, they get much healthier with exercise, especially endurance exercising, like jogging or running, or biking. Those kinds of exercises tend to really accelerate them and improve your mitochondria so you make more energy. And that's very important as we get older because it kind of counters aging and it also counters the effects of long-term sugar exposure. And you want to have healthy mitochondria that can make a lot of energy.
Right.
And there's a little bit of evidence that so this is stimulated when you exercise, but there's a little bit of evidence that the vitamin C may actually block that effect a little bit. So some people say you shouldn't take vitamin C before you exercise. But the other side of the coin is all the studies that show that vitamin C was bad with exercise are using doses of over 1 gram a day. So I think that if you're doing your neat idea of 250 milligrams before each meal, that's great. And if you're going to exercise, don't take any vitamin C before you exercise.
How does vitamin C seem to interact with fiber? Is there a good or a bad combination there, or there's really no interaction?
Well, there might be an interaction. I just don't know it.
Okay.
I'm a researcher, so I always am open to possibility, but I'm not aware of any.
Okay. So what are the takeaways you want people to have from reading this latest book? They'll understand now more how fructose works and how that's metabolized. But in addition to that, what do you want them to take away? What are some of the key concepts?
Well, here's a few of the big concepts. So the very first one is that fructose is different from all other calories in all other foods in the way it works. And most of the time when you eat any kind of food, it's being used to generate energy. And energy is known as ATP. And the energy that's ATP is the immediate energy we're using. There's also a stored energy, which is fat. So basically energy can be either kind of an immediate usable energy, we call ATP, or a stored energy, which we call fat. So when you eat food, most of the time it's being directed to make ATP. And if there's a little bit of extra, maybe there's some storage as fat, but really it's being used to make ATP. What fructose does is it sets up a series of unique reactions where it blocks the production of ATP and shunts the energy over to fat. And so you end up with a low energy state. You're inside your cells, your ATP levels are low, even though the total energy, if you take the ATP plus stored fat, may actually start going high, because as the ATP levels are low, it makes you hungry, and it's sort of like an alarm signal, so you keep eating. But by keeping the ATP low, it's just like building up on the fat. It's a way to store the energy in the back room in what we call the adipose tissue. And so what happens is fructose leads to fat storage, and it does so by altering the energy levels inside the cell. Now, it's a brilliant mechanism that was meant to be good to help animals short term, but when you do it chronically, these energy factories that make ATP, what we call mitochondria, get damaged, because the way it suppresses the ATP production is to cause oxidative stress to those mitochondria, and it does it through a substance called uric acid. So fructose makes uric acid, and then the uric acid quenches the mitochondria and reduces the amount of ATP that's produced. And over time, that damages the mitochondria, and then you get locked in to a low energy state. And low energy isn't a really good thing, because you end up being tired. You end up not having the energy. You're storing more fat. If you try to lose weight, it's very hard, because you're in a low energy state that tries to keep you there. So that's why, blocking the switch is a great way to try to give you back your energy. And then also stimulating the mitochondria is a good thing too. So that's the first big message in the book. And then the second big message is that, guess what? It isn't just the fructose we eat from sugar and high fructose corn syrup, but the body can make fructose. This was really sad. And we published this in a Nature journal, and the science is pretty strong. But what happens is that, the reason, French fries are bad is not because it contains fructose, because it doesn't, but it contains high glycemic carbs. And when you eat potatoes and rice and bread, it raises the glucose levels in the blood a little bit, and that also triggers this biologic switch, because it converts some of that glucose to fructose. We make fructose is from glucose. So that's why high glycemic carbs are really bad. And a lot of people were thinking it was from stimulating insulin, but our work suggests that the main mechanism is through this fructose pathway, that glucose gets converted. And
So what's the difference metabolically if you just eat fructose versus it's being converted from glucose? Is there any, interesting dynamic there?
Same. It's the same. They both end up causing the same problem. They drop the ATP, makes you hungry and makes you become insulin resistant. It's the same. Once you make, it doesn't matter if you eat fructose or if you make fructose. They work the same way. And so what we learned sadly was that it isn't just sugar, but it's also these carbs that are mainly what we call high glycemic carbs, like rice, potatoes, bread, crackers, cereal. And they're equally as bad as sugar. And, but there's some tricks, though. So for example, like if you take a slice of bread and you eat it, you're going to get that glucose level is going to go up and it's going to trigger the production of fructose. And there's some studies that suggest that you can make the equivalent of a whole soda soft drink equivalent of sugar just from eating high glycemic carbs. But here's the trick. If you put things like avocado or something on the bread to slow the absorption so that the glucose in the blood doesn't go up so much, in other words, you block the glycemic, the release of glucose from the bread, you slow the release so it only goes up slowly, then you won't activate the switch. Here's another trick. If you take a soft drink and you drink it fast, you get that big slug of fructose. It goes right to the liver. It activates the switch, and it's activated by the concentration of fructose. But if you drink that same soft drink and you were able, and you won't be, but if you were able to just take one sip every 10 minutes over a 3-hour period, it would just be a calorie because you wouldn't get enough fructose to activate the switch. So one of the things that we've learned is, it's related to the speed with which you, whether you're eating it on an empty stomach or not. And all these little tricks came out of understanding the science. We did a study, with giving apple juice rapidly or over a much longer time, and you activate the switch if it's rapid. So that was a big discovery. The other really big discovery, Richard, was that you can activate the switch by eating salt. And
oh, really?
So, we always knew salt was associated with blood pressure, but a lot of people think of salt as healthy, but it's not so healthy. Not only does it raise blood pressure, but it increases the salt concentration in our blood. So when you eat French fries, and if they're really salty, you're going to get thirsty, right?
Right, yep.
Yeah, and then when you get thirsty, it's because the salt concentration's gone up in your blood. And when that happens, it triggers the reaction to convert glucose to fructose. So if you eat a French fry with no salt, it's still going to be converted partly to fructose. But if you put salt on it, it's going to really be turned into fructose. So salted chips are much worse than non-salted chips. Salted French fries are much worse than non-salted. And it's because the salt triggers the enzyme that converts glucose to fructose. Now, here's a real...
Sounds like, McDonald's is like the ideal meal. For destruction.
Oh, the meal of destruction. Yes, because the ketchup, it is sweeter than most ketchups because they put a little more sugar in it. And they got that big bun. And and then the soft drinks, oh my gosh, the soft drinks are by far your number one killer.
I interviewed Rob Wolf, and I forget which product. They have this one like corn chip product where one's really spicy, one's really salty, one's really sweet, all in the same package. And he said it essentially tricks your brain into like eating much more than you ever would want to, because I guess it's pushing all these buttons and activating all this stuff.
Yeah. What do they call that popcorn when they have the sugar and kettle corn or something, sugar and salt?
Yeah, there was another product he talked about and he called them up, and they did say they deliberately engineered it like that to have like maximum effect. So,
well, anyway, one of the cool things about the salt is it turns out that the way it works is it's converting the carbs to fructose. So if you're on a low carb diet, you're avoiding the sugar, you're avoiding the high glycemic carbs, and even if you're eating salt, you won't generate that much fructose because you're not eating the carbs that get converted to fructose. So that's sort of an interesting thing. But when we realized that salt could do it, it turns out it takes a lot longer to become fat from salty food. I mean, like if you give an animal salty food, it takes like 6 months before it gets huge. Whereas if you give sugar, it's like 2 months. So sugar is faster for sure, but
So
salt.
if you're to make a Pareto of bad things to have, is what would be the worst? Is it high fructose corn syrup or
High
tons of
fructose
fructose
corn
from soup?
syrup. High
Okay.
fructose corn syrup. It's even worse than sugar. We've done studies comparing the two, and high fructose corn syrup is your number one bad guy, especially if it's given in liquid form, like a soft drink with high fructose. Fountain
Right.
drinks, they even increase the fructose percentage. So high fructose corn syrup is usually a ratio of 55 to 45 fructose, 55 fructose, 45 glucose.
Mm.
But some fountain drinks can have 65%. It's just amazing, and that really activates the switch. So high fructose corn syrup, number one. Table sugar is probably right behind it. High glycemic carbs, these are your big guys. And then interestingly, salty foods will do it, but it just takes longer. And then the way high fat makes you fat is it's not the high fat itself that makes you fat. If you give an animal, like if we give an animal lard, they won't, if they're regulating their weight fine, they're not going to gain weight. But if we first give them fructose to make them hungry, and it triggers this thing called leptin resistance where you become really hungry all the time, we can take the fructose away. And now we give them lard and they gain fat really fast. And the reason is because fatty foods have like 9 calories per gram. They're very energy dense. So
Right.
if you can't control your appetite, then fatty foods are the fastest way to gain weight. So it's sort of like fructose sets you up. It makes you hungry, and then the high-fat foods are just like this whammy bar. It's just really allows you to amplify the weight gain. So sugar and fat do work together. It's not
So
yeah.
does this also suggest that if you change the order of things you're going to eat, would that provide you any more help? If you have the fructose last, let's say.
The trouble is once you're eating a lot of sugar, you become leptin resistant, so you become very hungry, and that can persist for up to like 2 weeks after you maybe even longer after you stop the sugar. So, for example, if I'm chronically eating a lot of sweets, I'm going to be leptin resistant, and I'm going to continue to eat a lot. But if I suddenly go on a low-carb diet or cut out carbs for 2 weeks, it will take about that long to kind of reboot the system where I'm now trying to regulate my weight. So, it's interesting. A lot of low-carb diets, they have kind of a 10-day, 14-day period where you're on kind of a severe carb restriction, and it's probably, I think it was figured out empirically, but this is probably why it works so well.
Yeah, interesting. Yeah, you mentioned that bears and some other animals will eat pounds of fruit in a day and put on 8 to 10 pounds a day. Is there any other mechanism you've seen that would take 8 to 10 pounds a day off? I'm not asking this for a diet program, but just scientifically.
Yeah.
Is there anything been observed that does it that fast in reverse?
Well, in order to get rid of the fat, you've got to burn it. And like intermittent fasting, low carb diets, these allow you to help burn the fat for sure. But you clearly don't want to be activating the switch while you're burning the fat. So if you go on a calorie restriction to burn the fat, but you're taking sugar as your calories, that's not good. I took animals and we put them on a severe diet where they were just eating, they were on a caloric restriction, but they had 40% of their diet as sugar, and they still became diabetic even though they weren't, even though they were on calorie restriction. And they still got fatty liver and hypertension. And so the trouble is it isn't just about calorie restriction and exercise and intermittent fasting, but you really do need to kind of reduce the foods that activate the switch. And you want to stimulate those mitochondria so that they get healthy again, so that you can maintain, so that when you lose the weight, you can end up eating like you used to, but not gain the weight back. And so that requires, things like the exercise. So there's all kinds of tricks that come out of this from understanding this.
I know the Warburg effect says that damaged mitochondria, are a marker of cancer. Have you been able to? I know you can't research everything, but has anyone taken your research and said, hey, this will also inspire cancer to happen?
Oh, we did actually, and also a lot of other investigators. So it turns out, remember that fructose was meant to be a survival pathway, right? So by reducing the amount of energy produced by the mitochondria, it also, keeps, what it does is it helps the animal survive kind of in a low energy state. But one of the things that it happens is that the mitochondria use a lot of oxygen to make ATP. So when you reduce the amount of ATP you're producing, you're also reducing the amount of oxygen you're using. So it turns out that animals under low oxygen conditions tend to try to activate this switch as a means to survive. So there's this naked mole rat, for example, that lives in these burrows in South Africa. And when it goes in those burrows, there's very little oxygen. So it starts to make fructose, because when it makes fructose, it reduces its energy production and reduces its oxygen. So it was meant to be like a survival factor. But guess what? Cancer cells like low oxygen settings. They live in low oxygen settings, because when the cancer cell metastasizes and it goes to another organ, and it sees another organ, it doesn't, in the beginning, doesn't have a blood supply. So it's living in a low oxygen state. So it wants a fuel that really will help it survive a low energy state. And sugar and high fructose corn syrup turns out to be the perfect fuel. So, you can give high fructose corn syrup and tumor cells love it. And in fact, there's evidence that it can help cancer spread. It doesn't cause cancer. It's just helping it survive through this Warburg effect, which is what you're talking about. So we've done some studies, and it turns out that, remember I mentioned that uric acid is the substance that fructose makes, and that's the thing that quenches those mitochondria. And when we treat tumor cells with uric acid or raise the uric acid, we can show that we can increase the risk for metastases in animals, for the spread of the cancer. So it turns out, fructose is playing a role in cancer. And
this sounds like it's intimately tied into that whole process.
Yeah.
What if someone has chronically high uric acid and they just don't know why? What would you say? Like, what would be a hint to look at? I guess their fructose intake, or what are your thoughts?
Yeah, and if you have chronically elevated high uric acid or chronically elevated uric acid, that is associated with being obese. That's associated with being diabetic. So it's not just associated with this disease we call gout, which is when the uric acid crystallizes in joints. If you have a high uric acid, you're at high risk of either developing obesity and diabetes or being obese and diabetic. So there's a very strong relationship. And one of the primary ways to get a high uric acid is to eat a lot of sugar. So if you're eating a lot of sugar, that can do it. But interestingly, you can raise uric acid other ways. And one way, like drinking beer and alcohol, and especially yeast extract, which is in beer, they can raise uric acid. And we have shown that this can also trigger this biologic switch. So it turns out that after sugar and high glycemic carbs, things like beer can also activate this switch, and it's doing it by raising uric acid levels. And there's certain other foods that can raise uric acid levels and can trigger the switch as well. So there are, I wouldn't, for example, eat a lot of shrimp. Small amounts are fine, but if you're eating huge amounts, you could be getting enough of a load of purines to raise your uric acid and to trigger the switch. So you can do it that way. It's sort of depressing, Richard, because there's a lot of foods that we love that can activate the switch, but there's also ways to turn off the switch too. Drinking water, for example, 6 to 8 glasses of water a day. avoiding a lot of salt. These tricks like low-carb diets and intermittent fasting, they all can help. And then I actually put together a diet that I think is quite reasonable and that can also.
Yeah, no, it's very interesting. Well, very
Yeah.
good. Rick, so is your book available on Amazon and Kindle and everywhere yet, or is it slated to come out shortly? Like, what's the date?
It came out in February, so it's available
Okay,
through
excellent.
almost all these sites. I think most bookstores carry it, Amazon, Books A Million, Barnes & Noble. I also have a website, drrichardjohnson.com. And also, I can be reached on Instagram at Dr. Richard J. Johnson. And so there's lots of ways to find out about the book.
Excellent. Well, Rick, it's always great to talk to you. Thank you so much for coming back. And definitely encourage people to read your book. It's a lot to think about. And I know a lot of people have problems with obesity, with uric acid, cravings, so if it explains it all and gives people a method on how to help themselves and reasons why, that's great. It'll be very useful.
Thank you, Richard. It's always great to be on your show.
Don't forget, before you go, use code GENIUS at Viome.com for an additional $20 off your health intelligence test and get started on your health journey with the right foods, supplements, and probiotics and prebiotics for your unique biology. Get a deeper look within with Viome's health intelligence test. Viome, you decoded.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.